Good day, everyone. I have a question for you all. Have you ever wondered if listening to music while studying helps you remember more? We all listen to music in the background, whether we're studying notes or memorizing. But does it really make a difference? Today, we're going to answer that question using a simple but powerful method called hypothesis testing. We'll use data collected by a real group of students to see if music really does have an effect on memory retention. So let's begin.
The objective of this presentation is to demonstrate how to use hypothesis testing with one group of students who study with music, and to determine whether their average memory recall is significantly different from the general population average of students who study without music. By the end of this presentation, you will not only know the answer to our question, but understand how hypothesis testing works and how to apply it in other real-life situations.
Let's talk about hypothesis testing. It might sound complicated, but really, it's just a structured way of using data to confirm or reject a certain claim. In hypothesis testing, we have two main ideas. Number one, null hypothesis. This is our starting assumption. It says that there is no difference or effect. In our case, the null hypothesis states that the students who study with music have the same memory recall as those who studied without music. In numbers, that's an average recall of 12 words. Number two, alternative hypothesis. This is what we test for it. It suggests that there is a difference, that the average recall of students who studied with music is not equal to 12 words. It could be higher or lower. Now, when we test this hypothesis, we are looking for enough evidence in the data to reject the null hypothesis. If the evidence is strong enough, you can say that music likely does have an effect.
Key concepts. We are using something called a two-tailed z-test. Why two-tailed? Because we are checking if the average is either higher or lower than the known value, not just higher. And we set a level of significance at 0.05. This simply means we are 95% confident of our decision.
Now let me tell you about our data collection. We gathered data from a group of 10 students who studied with music. After the study session, we had them recall as many words as they could from the word list that they had studied. The average results were interesting. On average, the students were able to recall 14.4 words. Their scores varied slightly, with a standard deviation of 1.17 words. We will compare their average score of 14.4 words to the known population average of 12 words for students who studied without music.
Step 1. Identify the given data. Let's identify the information we have. First is our X bar is 14.4. Next, our mu is 12. Our standard deviation is 1.17, and our sample size is 10. And next is our null hypothesis is mu is equal to 12, and our alternative hypothesis is mu is not equal to 12.
Step 2. We will now determine when to reject the null hypothesis. For a two-tailed z-test at 0.05, the critical z values are 1.96. This means if the calculated z-score falls beyond 1.96 or below negative 1.96, we will reject the null hypothesis. If it falls between those numbers, we will accept the null hypothesis.
Step 3. Solving the problem. The formula that we are using is this. X bar minus mu over standard deviation over square root of our sample size. 14.4 minus 12, 1.17 over square root of 10 equals to 6.48. Hold up, 6.49 is quite a large number in this context. It means that the average recall from our group is very far from what we would normally expect if music didn't make a difference. Step 4. Make the decision. Remember, our critical values were positive and negative 1.96. Our calculated z is equivalent to 6.49. And this is way beyond or greater than 1.96. That means that we have enough evidence to reject the null hypothesis. And here's the best part, our conclusion. At the level of significance of alpha equals 0.05, the average number of words recalled by students who studied with music is not equal to 12. Since our result was on the positive side, well beyond the cutoff, we can say that music positively impacts memory recall. In simple words, students who studied with music remembered more words than those who didn't. So, what have we learned today?
So, I've seen how hypothesis testing works, and how we can collect data, and how we can analyze it step by step.
We started with a question. Does music help with memory? We tested it using real data, and the numbers spoke for themselves.
Yes, it does. But more importantly, I hope we've seen how statistics can turn curiosity into clear scientific answers. Whether it's in education, health, or business, these methods can guide smart decisions.
Anyways,
Thank you for listening.
If you have any problems or any problems about this video, then feel free to ask us.
We'll
In
be
case
happy
if I
to
don't see you, good morning, good afternoon,
And good night. When gimingaw ka ni shine, alak ka when
Check the clock.